Every major product program eventually hits the third cut. It is the boardroom meeting where someone finally says the word decontent out loud, and executives scramble to hack away at the budget. A premium trim finish turns into standard plastic molding. A highly tactile physical switch gets buried inside a touchscreen menu. But the tension in this room is misplaced. The money they are trying to save isn't being committed on a purchase order today. It was decided in a room months earlier by people drawing concepts. Trying to control costs after the quiet, early-stage design work is finished is an exercise in futility. By the time the tooling quote comes back, the financial damage is already done. NASA's Systems Engineering Handbook puts a specific, brutal number on exactly when product costs are finalized. Financial flexibility vanishes quickly during a project's timeline. The moment a preferred architecture is selected, up to 70% of the product's lifecycle cost is permanently locked in. By the time a preliminary design is chosen, that figure hits a staggering 90%. This creates a massive dilemma for engineers and designers. The absolute most critical financial decisions must be made precisely when the team has the least amount of information about their alternatives. Slashing budgets at the third cut doesn't save money. It simply takes the consequences of an uncontrolled, overly optimistic concept phase and distributes them onto the things the final customer can see and touch. When a flawed concept escapes the design studio, its financial weight doesn't stay static. Instead, it aggressively compounds. A study commissioned by the National Institute of Standards and Technology tracked independent data sets to measure exactly what it costs to fix a defect depending on when it is found. This visualization tracks the relative cost to repair a design defect. If caught early in requirements, the fix is our baseline, 1x. Surviving to system testing multiplies the penalty to 90x. Reaching the operation and maintenance phase, the cost skyrockets to an astronomical 2900x. Catching a problem late in validation is not a minor setback. It is an exponentially fatal financial blow that devours profit margins. The most reliable way to miss a cost target is falling for the carryover trap. It is incredibly tempting to look at a reused, pre-existing part and assume it is a solved problem that will save money and reduce engineering risk. A NASA paper on rebuilding flight-proven instruments states clearly that these build-to-print designs give a false appearance of minimal development cost. In reality, they hide massive, unanticipated ramifications. A seemingly identical seat frame carried over from last year suddenly meets a new safety regulation. An existing headlamp requires a totally new lens to match an updated brand language. Researchers at Goddard note that teams frequently lock these designs in prematurely. It happens because study funds dry up, early optimism sets in, and intense pressure to meet a milestone deliverable forces a decision before engineering is verified. Because these carryover parts are marked green on a spreadsheet, they bypass early scrutiny. The parts deemed the safest actually harbor the highest uncalculated risks. Sometimes an uncontrolled concept phase costs a company its profit margin. Other times, the cost is measured in human lives. The Takata airbag recall is one of the most devastating examples in modern manufacturing of a single early material decision creating a delayed disaster. During the early design phase, Takata engineers chose an ammonium nitrate-based propellant for their inflators. Crucially, they decided not to include a moisture-absorbing desiccant, making the chemical highly susceptible to long-term degradation. As the propellant degraded over years of exposure to humidity, the inflators became unstable, rupturing and firing twisted metal shrapnel directly into the vehicle's cabin. A material decision taken early in the concept phase sat dormant, only revealing its true, catastrophic cost a decade later. How do disciplined engineering teams survive the inevitability of this compounding cost curve without sacrificing the integrity of the final product? They use a method called target costing. Instead of building a product and seeing what it costs, they invert the arithmetic. The competitive market price is treated as a hard input, not an accidental outcome. They mandate formal value engineering during the concept phase. This means running a rigorous review of the architecture, using outsiders, people not emotionally attached to the design, who can spot hidden liabilities. Navigating this critical window requires tools that match the gravity of the outcome. Whether utilizing the design intelligence of platforms like Depix or running rigorous bottom-up should-cost modeling, The goal is to map the underlying drivers before they are locked in. Early design decisions are as cheap as an afternoon sketch, but they are brutal once put into production. The third cut will always come. What survives it depends entirely on seeing every angle before you ever start to build.